Hello, today we are going to look at 3-6 solving inverse trigonometry, and our objective today is to find all angle solutions to trig equations with horizontal vertical transformations, mainly with a calculator today. So let's look at kind of the concept of what this would look like graphically. So we've got our sinusoidal graph here in red, and we have an equation here in black. And we want to figure out what are the solutions to this graph. And when it says what are your solutions, basically all it's asking for is what are our intersection points. So I'm just looking for intersection points. And that's going to be my solution. So if you look here, my answer is -2, 6, 10, 18. And as you can see, as I would go both directions, we know our sinusoidal graphs go on forever. So there is really infinitely many solutions. But the ones showing on our graph are these points right here. So what we're going to do is we are going to use the material we learned from last chapter as far as writing our sinusoidal graph. And we're going to come up with an equation for this. So we start with the idea that my max is 7, my min is -1. So that would give me a sinusoidal axis of, so add them up, 7 plus -1, which is -6 divided by 2 would be 3. So my sinusoidal axis is 3. And then if I look at my amplitude, how much did it go up? Well, from 3 to 7, it's 4. From 3 to -1, it's 4. So my amplitude is 4. And then our period, so we look at the length of one cycle, which starts at 2 and ends at 14. So my period is 12. And remember, that doesn't actually show up in the equation. The b value does, so we need to use the equation that b equals 360 divided by 12. And so b equals 30. And so the equation for my sinusoidal graph is going to be, let's put all this information together. I have my amplitude, which is 4, my sinusoidal axis, which is 3. It starts at its max, so I'm going to be the cosine curve. I found my b value is 30. And the other thing we didn't talk about is the shift, and it's shifted right 2 units. So I'm going to go x minus 2, and that's the equation. And then I write the equation of the black line, and the black line is just y equals 1. So basically what is being asked by this curve is to look at solving that equation. So of course we're going to not only just do this graphically, but we are going to do this algebraically as well. So this is an equation. Our ultimate goal is to get an equation like this and solve it algebraically. And we're going to use our calculator to check to make sure we're doing all of our math correctly. All right, so let's start basic. We want to just find all our solutions for cosine theta equals 0.3. So I'm going to go to my calculator, and I'm going to go make sure I'm in the right mode. So I want to be in degrees. We're actually going to stay in degrees on this video today. We'll talk about radians more in class. All right, so now I'm in degrees, and so now I'm going to go second cosine 0.3. because I'm looking for angle measures, and I will find my answer is 72.5. All right, but that's not the only answer. So keep in mind what we've done in the past, and we've looked at the idea that, okay, cosine is x, and x is positive in the first quadrant and in the fourth quadrant. So if this is the 72-degree angle they gave me in the calculator, the one they don't give you is this one right here, where we're looking at going all the way around. But that's easy to get because all you have to do is 360 minus your 72.5. And if I do that, I end up with 287.5. All right, let's look at it graphically. y equals, I'm going to put cosine of theta in one, and I'm going to put 0.3 in the other. And then I'm just going to do zoom. Let's mess with my window. I'm going to go from 0 to, let's just go to 720. And I'm going to do a scale of 90. And I know cosine goes up to negative, or up to 1 and down to -1. So I'm going to go from -3 to 3 just so I can see a little bit above and below my graph. So here's my graph. And as you can see, this goes on forever. If I want to find those solutions graphically, all I have to do is use the intersection button on my calculator. So I do second, calc, intersect, and then I usually arrow to my straight line so I can go over quicker. And then just hit enter 3 times once you get near the intersection you're talking about. And since we did this work already, we should know the answer should be about 72.5. And that's what we got, so 72.5. And then we go through and do it again. So second, calc, intersect. Now I want to be over on the other one. So I arrow over and do second, enter 3 times. So I can enter, enter, and enter. And my answer should give me the 287.5. Now, if we look at this in our circle, we know that we can also start from here and go around all the way around and get another angle. And that red angle is just going to be 360 plus the 72. And the 360 plus the 72 ends up with 0.5. 432.5. And if I go find this other intersection point on my calculator, second, calc, intersect, my first curve I hit enter, my second curve I hit enter. Now I'm going to guess, so I don't have to keep hitting with my arrow. I'm guessing my answer is somewhere around 430, so I'm going to put 430 in there. And look, I get 432.5. And we just keep going with this until we find all of our solutions. So if I intersect this one, I ended up with 647.5. My graph didn't go out far enough because I wanted to see 4, or 5. So then I need to get that next one, which is basically just going to be 792.5. And how that one comes about is just looking at, now instead of looking at going around once, I'm going to go back around and hit it again. So I'm really doing 72.5 plus 360 times 2. All right, let's step it up a notch. Let's solve this one. Well, the first thing you have to do, if you're going to solve it using your unit circle kind of idea, is you divide by 5. Divide by 5, and you get cosine theta equals 3/5. Go to my calculator, do second cosine of 3/5, hit enter, and I get 53, and I'm just going to round to 53 degrees. 53 degrees. All right, so 53 degrees is going to be here in the first quadrant. And then we also know, again, just like the last one, cosine is positive, so we're also doing a 53-degree angle here. Just make it look a little bit more like it's actually 53. All right, and so my other answer is just going to be 360 minus the 53 degrees. And so that answer is 307. Okay, and then if we keep looking at this, I can go all the way around and add. So basically my next angle could be 53 plus 360. And if I do that, I end up with 413. And then I could also do the same thing with the blue angle. So I could start here, go all the way around and back. So I'm taking the blue angle, which is 307, and adding 360 to that as well. And so that answer ends up being 667. And as you can see, we can keep going round and round in circles. So what we do for all solutions is we write theta equals the 53 degrees plus 360 times k. That's half of them. And then the other half is going to be the 307 degrees plus the 360 plus k. And that k just can be any integer, so we can keep going around the circle a number of times. All right, we step it up one more. Now we got a couple other things to do. So algebraically first, I'm going to solve this. I'm going to put it over here so I have more room. So I have subtract 4, and I have 2 cosine of 5 theta equals -1. I'm going to divide by 2, and then I'm going to ignore the 5 for right now, and I'm just going to say what cosine of what angle gives me -1/2. Hopefully we're talking to ourselves about our exact values. We know we should be in these two quadrants because cosine, the second and the third, cosine is negative there. And so hopefully you're saying to yourself, oh, well, that's going to be a 60-degree angle here and a 60-degree angle here. So I'm looking at 120 degrees, and I'm looking at 240 degrees. All right, but then again, because we can go around the circle infinitely many times, we add the multiple 360k to it so that it gets all the solutions. Now this isn't equal to theta though. This is actually equal to 5 theta. So there is one more step we need to do, and we need to solve for theta, which means we divide by 5. And so my answer should be 120 divided by 5, which is 24, plus 360 divided by 5, which is 72k. So those are half of your solutions for theta. Your other half is just going to be take this equation down here and divide everything by 5, and theta equals 240 divided by 5, which is 48, plus 72k, and these are your other solutions. And again, we can do this by plugging these answers into our calculator. So graphically, if we're checking, we're going to put the 3 into the y1 equals, the 4 plus 2 cosine 5x into the y2 equals, and then we go to change our window. We probably want to go from 0 to 360 at a scale of 90, and from -2 to 8, simply because if it's looking at your max value, we know our sinusoidal axis is 4, we're going to go up to 2. So I just wanted to give myself some room on my window there. And then if I graph it, I'm looking at these points. And again, to find those intersection points, you go second calculate, intersect, and then hit enter, and I kind of like this guess feature because I kind of know what my answers are. I know my answer is going to be the 48 and the 24. So if I guess 24, it's going to show you my intersection point. Of course, this is that I've already done the problem. So if I don't know, I have to go to second calculate, intersect 1, 2, and arrow over, hit enter, and it'll come up with the second one. And again, we can keep going on and on and on with these. And you'll end up just basically adding the 360 to them, which makes all of these answers show up. So then this would be 96, this would be 120, etc., etc.